All right, chapter 4 is about the muscular and the skeletal systems because they really work hand in hand. And as I mentioned in the previous one, now that we're into the organ systems of the body, I'm just going to briefly talk about the functions and the anatomy of the system, and then go right into the word parts that are specific to these systems. And that's going to be the architecture of all the videos that follow. So the functions of the musculoskeletal system, simply for muscles, there's three kinds of muscles. This chapter is really going to deal with the skeletal muscles. Smooth muscles, cardiac muscle, and skeletal muscle, sometimes called striated muscle. Smooth muscle you'll find anywhere you have a hollow space that you need to control the size of. So you'll find it in the walls of the digestive tract, you'll find it in the arteries and veins, you'll find it in the bladder and the uterus, that sort of thing. Cardiac, obviously, is the heart itself, the heart muscle, and skeletal are all the muscles that are attached to bones. Regardless of the kind of muscle, all muscles get shorter, they contract, and that contraction results in some form of motion. For example, the smooth muscle of the digestive tract, when it contracts, it moves food through the digestive tract. When the heart contracts, it moves blood through the circulatory system. For striated muscles, when they contract, they move bones, and that results in the movement of the bones or the whole body. As far as the skeleton goes, it's got a lot of jobs. Obviously, it's structural. It holds our shape and our form, but they also act as levers, so that when muscles pull on them, that moves the lever that moves objects in our environment or moves us through our environment. Certain bones are protective, so the cranium and the vertebrae protect vital organs. The rib cage protects the lungs and the heart. They have a metabolic role because in the center of the bones you find bone marrow, and bone marrow is where we create all the white blood cells, red blood cells, and platelets, all the cells of the blood. And the white blood cells make up our entire immune system. Red blood cells carry oxygen from the lungs to the tissues, and our platelets allow us to stop blood loss by forming clots. And then storage. So not all bone marrow makes blood cells. Some bone marrow is called yellow marrow, and that's fat tissue, that's adipose tissue. So you can store fat in your bones, particularly as adults. As children, most of our marrow is red bone marrow that makes blood cells. Bones also store minerals like calcium and phosphorus and fluoride, and all sorts of minerals can be stored in the bones. When we look at skeletal muscle, and again, that's what we really care about. We have a whole chapter about heart muscle in the cardiac chapter. So what we really care about here are skeletal muscles. It's kind of a nested structure. If we start at the smallest end, the microscopic end, you have myofibrils that are made of individual proteins. These are contractile proteins. These proteins are what make the muscle get shorter. And inside a single muscle cell, you find basically a muscle cell the volume of it is filled with these myofibrils that extend lengthwise through that single muscle cell. Single muscle cells we refer to as muscle fibers. Muscle cells are bundled together into what are known as fascicles. So this is a fascicle, and each one of these is a single muscle cell. And then there's connective tissue around it called the endomysium. When you bundle a bunch of fascicles together, you get the entire skeletal muscle. And again, it's got connective tissue running between the fascicles. And then the whole muscle itself is surrounded by a fascia. I'd love to get more into it, but take a nat and phys, you'll learn more about it. So here are some words that relate to the particular muscle, skeletal muscle and movement. So the words teno, tendo, and tendino all refer to tendons. Tendons are connective tissues that join muscle to bone. So tendodinia would mean pain in a tendon. Tendolysis would probably mean a loosening of a tendon. Tendinitis means an inflammation of a tendon. Musculo, myo, and myoso all refer to muscle, and they can refer to any type of muscle. So we saw that in musculoskeletal system, you can have a myopathy, which is a disease of a muscle, or a myositis, which is an inflammation of a muscle. The connective tissue that surrounds an entire muscle, as I mentioned before, is called a fascia. This root, fascio, refers to that connective tissue that surrounds the muscle. So fasciotomy would be an incision into that fascia. Or fasciitis would be an inflammation of that connective tissue. Tono refers to how much tension there is in a muscle. How much muscle tone does it have? Dystonia literally means a condition of bad tone. A tonograph measures how much tension is in a muscle. Taxo refers to a position or a classification, in this case a position, or it can refer to tension as well. So ataxia means no tension in that muscle. Hypotaxia, not enough movement in that muscle. Kinesio and kineto both mean movement. So kinesiology is the study of movement. Hyperkinesia means too much movement, so unwanted movements. So maybe it could be a tremor, something you might see like in Parkinson's disease. And of course, kinetic energy is the energy of movement. Ankylo, notice it's spelled with a Y, it's not like your leg joint in your lower leg, means a stiffening. So ankylosis is a condition of a stiff joint. Or ankylodactyly means stiff fingers. Dacty means fingers. Dactyl or toes. So any fingers or toes. So ankylo means a stiffening. So the anatomy of the skeletal system, you can see that it begins in the embryo pretty much as cartilage. And the cartilages are placeholders where bones will ultimately form. During the development of the embryo, this is how long bones are formed. You form a collar of very hard, compact bone around the middle, and then you get what's called a primary ossification center. That's where you digest away a certain amount of cartilage, and you begin, bone cells actually begin building the bone itself. And then as time goes on, you get infiltration of blood vessels to feed those osteoblasts that are making the bone. So you're digesting away the cartilage and replacing it with bone. It's not cartilage turning into bone. It's cartilage being digested away and being replaced by bone. And oftentimes you'll have secondary ossification centers at the ends. The ends of the bones are separated from the shaft of the bone by a layer of cartilage that's known as the growth plate or the epiphysis. The epiphysis. In the adult bone, this would be an adult bone, that epiphysis is sealed completely with bone, epiphyseal line. The only place you'll find cartilage remaining is on the articular surfaces, the surfaces where this bone meets another bone. In this x-ray over here, this is of a child's wrist, and you can see right here, cartilage is less dense than bone, so it doesn't show up on x-rays as well. So this is a layer of cartilage that is the epiphyseal or growth plate in the ulna and the radius here, separating the end of the bone from the shaft of the bone. So that's the epiphyseal cartilage plate. When this child stops growing, grows up, that cartilage goes away, is replaced completely by bone. At that point, that bone can no longer grow in length, and the child has stopped growing. This is an adult. The shaft of the bone we refer to as the diaphysis, and they show it being hollow here. Normally that would be filled with bone marrow. And in the case of the femur, that would be red bone marrow, creating white blood cells, red blood cells, and platelets. All around the exterior of the bone is this very hard bone called compact bone. And then at the ends, you see this, what's referred to as spongy bone at the diaphyses. I'm sorry, at the epiphyses. The diaphysis is the shaft. The epiphyses are the ends. It looks spongy, but it's very, very hard. And it gives a lot of strength to the bone without adding a lot of weight. There's a lot of hollow space in there. And here you can see the epiphyseal plate that has been sealed with bone. No more cartilage left. We're not going to name all the bones. We may refer to specific bones here and there in this chapter, but if you want to know all the names of the bones, take anatomy and physiology. We'll just go over some of them here. The axial skeleton is made up of the cranium, skull, and the vertebrae, which are made up of 7 cervical vertebrae, that means neck, the 12 thoracic vertebrae, that means chest, 5 lumbar, which is the lower back, and 5 fused sacrum, 5 bones, 5 vertebrae that are fused into the sacrum, which sits in the middle of the pelvis. And then Your tailbone, 3 to 5 fused coccyx vertebrae. It varies from individual to individual whether they have 3 or 5. The axial skeleton then includes the sternum, the breastbone running down the middle of your chest, and the ribs. And then, of course, the pelvis or the pelvic girdle, which is 3 separate bones that are fused together, the ilium, the ischium, and the pubis. The appendicular skeletons are your arms, wrists, and hands, legs, ankle, and feet. Again, we're not going to name each individual bone involved in that. Here are word parts related to the skeleton. Osteo means bone, so osteopathy means a disease of the bone. The periosteum, eum means tissue, peri means around, and ost means bone. There's a very thin connective tissue that surrounds the bone, every bone, called the periosteum. Cranial refers to the skull itself. So craniometer measures the size of the cranium. Craniomalatio would mean softening of the cranium or the skull. As I mentioned before, cervico refers to a neck. That can be a neck anywhere. In this context, we mean the neck of the vertebrae. You have cervicitis, you have an inflammation of those vertebrae. Spondylo refers to vertebrae. If you have an inflammation of the vertebrae, that's an inflammation of the bone itself. Lumbo, as I mentioned before, refers to the lower back. So the lumbar spine or lumbodynia. Lumbodynia refers to pain in the lower back. Brachio refers to the arms. So brachiocephalic would refer to both the arm and the head. You have a brachiocephalic artery. Brachialgia means arm pain. Dactylo, as I mentioned, refers to your digits, your fingers or toes. So adactyly means you don't have any fingers. Dactylasia means you have pain in your fingers. Carpo refers to the wrist. So carpectomy means removal of one of the wrist bones. A metacarpal, meta means on top of or above, and so those are the bones of the palm. So they're distal to the wrist bones. Costo refers to the ribs. You might have a rib removed, ostectomy, or talk about something in between the ribs, like muscles that occur between the ribs. Those are intercostal muscles. Femoral refers to the largest bone in the body, the femur, and as in the femoral artery. AL means referring to the femur artery. Tibio is your shin bone. So if you have pain in your shin bone because you just bumped into furniture, you have tibalgia. Tarso are the ankle bones. So tarsitis is an inflammation in those bones. Tarsalgia would be a pain in those bones. The other thing about muscles and skeletons and bones is they come together into joints. There's 3 different kinds of joints. There are immovable joints, and you'd find those, for example, between the frontal bone and the temporal bone in the skull, where they don't move in relation to each other very much. Then you have slightly movable bones. The vertebrae don't move very much in relation to each other, in relation to their neighbors. The wrist bones likewise don't move very much. And then you have the joints that you usually think of as joints, the freely movable joints, your elbows, knees, hips. Those are all freely movable joints. Connections between bones. Ligaments join bone to bone. They're tough, fibrous connective tissue that joins bone to bone. As I mentioned before, tendons join muscles to bone. They both cross joints. They're both involved in joints. As far as words relating to joint movements, as we mentioned before, abduction, they're moving away from the center line. Adduction means moving towards the center line. Flexion means decreasing the angle between bones. So if you bend your elbow, you're flexing that joint, your elbow joint, because you're decreasing the distance between the ulnar radius and the humerus. When you extend that joint and you put your arm out, then you're increasing the angle between those bones, and so you're extending it. Hopefully you covered those in chapter 2. So here are some more parts related to joints. Chondro means cartilage. So if the cartilage is inflamed, you have an inflammation, it's chondritis. If it hurts, you've got chondrodynia. Arthro means joint. So inflammation of a joint, for whatever reason, is arthritis. There are lots of different kinds of arthritis. Or maybe you need arthroscopic surgery. That's where they actually open you up to look at your joint. A bursa is a sac that's filled with fluid that sits between a tendon and a bone. So tendons cross joints and joints have to move. That means tendons often rub against bone. In any given joint, you may have a bursa that sits between the tendon and the bone to cushion the movement of the tendon over the bone. If that pillow of fluid, the bursa, is inflamed, that's bursitis. If you've got to remove it because it's chronically inflamed, that's a bursectomy. They'd probably replace it with something artificial.